We remember the moon like a conquered mountain, grainy footage, a flag, a footprint pressed into dust that never forgets. And because that image lives in our collective memory, Mars feels like the next obvious step, almost inevitable. A slightly longer road trip, a red dot we've stared at since childhood, just waiting for us to arrive. But that intuition is a trick of perspective. The moon was not the first chapter of interplanetary travel. It was the last chapter of staying close to home. Because what we've truly mastered is not space. It's the thin shell above Earth, our planet's immediate neighborhood. A few hundred kilometers up, we glide through low Earth orbit, where rescue is conceivable, resupply is routine, and the planet still dominates the sky like a protective god. The International Space Station is, in cosmic terms, almost touching the atmosphere. If Earth were the size of a globe on your desk, the ISS would be a film of dust hovering just above its surface. We call it space, but it is still Earth's domain. The moon is different, and even that difference is easy to underestimate. Apollo didn't just go higher, it left the local rules behind. In 3 days, the astronauts crossed a gulf so wide that the Earth shrank from a world into an object. The mission had a simplicity that was brutal and elegant go-land return. A sprint across a void, timed and fueled like a bullet. Mars is not a sprint. Mars is the moment you stop orbiting Earth and start orbiting the Sunday. The destination is not parked in the sky like the moon. It's a moving world circling a star at tens of thousands of miles per hour. And to reach it, you must join the traffic of the solar system itself. That single change, leaving geocentric safety for heliocentric reality, turns a heroic journey into a compounding equation. And then there is the distance, the first cruel multiplier. At its closest, Mars is still tens of millions of miles away, and closest is a rare alignment that returns roughly every couple of years. Miss that window, and the universe doesn't offer sympathy. It offers more time, more fuel, more risk. Every day becomes inventory: oxygen, water, food, power, spare parts, medicine, shielding, sanity. Everything you forget becomes a problem you cannot mail. So the paradox isn't that we lack courage. The paradox is that Mars is close enough to haunt us, yet far enough to punish every shortcut. To go there, you don't just launch a crew, you launch a small, fragile world. And you must keep that world alive while the real one disappears behind you, shrinking into a bright star you can no longer reach by turning around. To understand why Mars is so hard, we have to zoom out until the maps in our minds finally match the geometry of space. Because most of what we call spaceflight happens inside a surprisingly tiny arena, low Earth orbit. Up there, you are still wrapped in Earth's gravity well, still moving to Earth's rhythm, still living under the faint protection of its magnetic field. The numbers expose the illusion. The International Space Station circles only a few hundred kilometers above the surface, closer than the distance between many cities on Earth. That proximity is why we can treat orbit like a place we visit and return from on schedules, with contingencies, with cargo ships and backup plans. The moon was the first time we stepped outside that arena. It sits nearly 400,000 kilometers away, 1,000 times farther than the altitude where most astronauts live and work today. Apollo made that crossing in about 3 days, and even then, the scale jump was enormous. The spacecraft had to carry everything it needed, because there was no quick rescue, no convenient shipment of spare parts, no next launch to fix a problem. Yet even the moon remains gravitationally tied to Earth. In a sense, it's still part of our system, our immediate neighborhood. Mars changes the reference frame entirely. The moon orbits Earth. Mars orbits the Sunday. Reaching Mars means you are not simply traveling outward. You are changing which world you belong to. You leave an Earth-centered orbit and enter a solar orbit, one that must intersect the path of another planet at precisely the right moment. That's why trajectories to Mars feel less like going somewhere, and more like performing a timed exchange in a celestial dance, where being early is useless, and being late is catastrophic, and Earth and Mars do not stand still for you. The distance between them breathes. Sometimes the two planets align on the same side of the sun, and the gap can shrink to around 30-something million miles. Other times they are separated across the solar system, with the sun itself between them, and the distance becomes not merely larger but strategically unforgiving. We can't aim a rocket in a straight line and chase Mars like a car on a highway. In space, straight lines are expensive. The efficient paths are arcs, transfer orbits designed to trade time for fuel. This is where the moon comparison becomes a trap. Apollo was a short, intense mission, a controlled burst of propulsion, a landing, and a return. Mars is a long-haul expedition governed by windows, not whims. Every 26 months or so, Earth and Mars line up in a way that makes the trip feasible with reasonable energy. These launch windows are not suggestions. They are physics granting temporary permission. If you launch at the wrong time, you either carry an impossible amount of propellant or accept a mission length that turns human endurance into the primary limitation. So when people say, "We went to the moon 50 years ago, why not Mars?" the answer is hidden in what they're comparing. Low Earth orbit is like living on your porch. The moon is like a daring expedition to a nearby island, dangerous but within reach, with a return plan measured in days. Mars is moving to another continent, while the ocean itself is trying to kill you, and the ship cannot stop, cannot turn back easily, and cannot be resupplied once it leaves the dock. The science is not just distance, it's the way distance multiplies everything else. A few days becomes months, months become years. And in that shift from a brief voyage to a sustained exile, space stops being a destination and becomes an environment you must survive. Once you accept the true map of the journey, the next realization arrives like vertigo. Mars is not difficult because it is far in the way the moon is far. Mars is difficult because it is far in time, and time in space is a tax you pay in mass. The closest approach between Earth and Mars is a rare moment of mercy. A window that opens only when the planets align in a favorable geometry. Roughly every 26 months, the solar system briefly arranges itself so a crew can ride an efficient arc, an interplanetary shortcut carved by orbital mechanics. That window is everything, because the moment you miss it, the trip doesn't become a bit longer. It becomes fundamentally different. You need more energy to intercept Mars, more propellant to break into arrival, more propellant to leave, and often far more time. And every extra day in transit is another day you must keep human beings alive inside a sealed machine. This is the escalation that people underestimate. Mars is a mission you don't just launch, you assemble, you stack. You build it in pieces because no single rocket, no matter how powerful, can easily lift an entire self-sufficient world into orbit in one clean strike. Life support systems, habitats, radiation shielding, food stores, spare parts, propulsion stages, landing vehicles, each element adds weight, and weight is the master variable of the entire equation. If you want more safety, you add redundancy. If you add redundancy, you add mass. If you add mass, you need more propellant. If you carry more propellant, you need a bigger vehicle to carry that propellant. And the spiral continues, a feedback loop of engineering reality. We've seen this progression before in miniature. Early human flights around Earth carried a single person and a capsule barely heavier than a car. Lunar missions demanded vehicles tens of times heavier, launched by rockets that were closer to skyscrapers than machines. Mars pushes beyond that again, because it stretches the mission from days into years. A lunar mission can survive on minimal supplies because it is short. A Mars mission is not short. A plausible round trip can require many months to get there, a long stay to wait for the next return window, and many months to come home, approaching 1,000 days of continuous life support. That duration changes the nature of risk. In low Earth orbit, a failure can be answered with a replacement. On the International Space Station, a broken pump, a failing component, a medical emergency, there is at least the possibility of rapid response. On a Mars trajectory, a broken pump is a potential death sentence. You cannot send a part fast enough to matter. You cannot send a rescue crew that will arrive in time. So the spacecraft must carry the solution to problems that haven't happened yet. It must be designed like a lifeboat that cannot see land for years. Then comes the most unforgiving requirement of all: propellant. In orbit, you are always negotiating with momentum. To go to Mars, you must accelerate out of Earth's grip, shape your path around the sun, and later cancel that enormous interplanetary speed to arrive safely. Every major change in velocity costs fuel, and fuel is mass, and mass is the enemy of launch. Estimates for a human Mars mission often reach into the hundreds of tons of propellant for the full architecture, sometimes approaching a scale comparable to or exceeding the mass of entire space stations. So, the obstacle is not a single wall. It's a cascade. The distance forces a long duration. The long duration forces more supplies, more shielding, more redundancy. That forces more mass, more mass demands, more launches, more assembly, more complexity. More complexity creates more failure points, requiring even more redundancy. And around the loop tightens, until Mars stops looking like a destination and starts looking like the ultimate test of whether our species can build a self-contained ecosystem that remains stable while it falls through the void. Mars is not a place you simply go. Mars is a place you earn by defeating the compounding mathematics of survival. And here in the deep water between worlds, the mission becomes less about rockets and more about biology, because beyond Earth, your body stops being you in the way you remember. In low Earth orbit, astronauts live in microgravity for months, and we already know what it does. Muscles weaken, bones shed density. Vision can change fluids, shift upward. The immune system behaves differently. Now stretch that into the scale of a Mars journey, months outbound, months inbound, and a long wait in between. The question stops being, can we get there, and becomes, what version of a human arrives? We do not yet fly ships like the ones in science fiction, vast rotating habitats that manufacture gravity through spin. So, the most realistic near-term plan is still the hardest, except near-continuous weightlessness and hope. Exercise, medicine, and discipline can hold the line. But holding the line is not the same as thriving, because arriving on Mars is not the end of the trip. It is the beginning of a new kind of labor in a suit, under pressure, in a world that does not forgive weakness. A crew that lands exhausted, deconditioned, and fragile is a crew that lives closer to the edge of disaster. And then there is the radiation, an invisible weather that never stops. Earth is not just a home, it is a shield. Our planet's magnetic field and atmosphere absorb and deflect much of the cosmic violence pouring through space, solar storms, energetic particles, the slow drizzle of cosmic rays that can damage DNA and increase cancer risk. On the way to Mars, you leave that shelter behind for months. Shielding helps, but shielding is mass, and mass is the currency you can never spend freely. We are still negotiating with a brutal trade protection versus payload. Time itself becomes corrosive. Machines wear down. Seals fatigue. Electronics age. Tiny failures accumulate in silence, and you must diagnose them without a hardware store, without an emergency supply run, without the comforting assumption that help is days away. Even conversation changes. Light is fast, but space is large. Messages take minutes to cross the gap, sometimes far longer. There is no real-time comfort, no instinctive back and forth, no immediate reassurance. You can speak to Earth, but you cannot truly be with it. So, the unknown is not just what Mars will do to us. It is what the journey will do first. Because the ship is not merely transportation, it is a world, and the moment it leaves Earth, that world becomes the only one its crew will have suspended in a place where every mistake is amplified by distance, and every delay is measured in minutes that can't be taken back. If Mars is a problem of time and mass, then the future of reaching it is not a single invention, it is an architecture. A choreography of launches, rendezvous, assembly, and staged propulsion built like a bridge across interplanetary space. The simplest image, a lone ship departing Earth in one majestic burn, is emotionally satisfying but physically unrealistic. What we are more likely to do first is quieter and more complex. Launch the pieces, meet them in orbit, connect them like organs in a body, and only then let the assembled organism leave its birthplace. This is why the conversation about heavy lift rockets matters so much. It's not just about power, it's about logistics. A vehicle that can place tens or someday hundreds of tons into orbit reduces the number of assembly steps, reduces the number of failure points, and shortens the time your hardware sits exposed in space before departure. But even with the most capable rockets imaginable, a human Mars mission still behaves like a campaign. Propulsion stages, habitats, supplies, landers, power systems, each one might require its own launch, its own checks, its own docking, its own margin for error. The first successful mission may look less like Apollo and more like constructing a small temporary space station designed to leave. Then we collide with the fuel dilemma, the most stubborn wall in the whole design. Carrying all propellant from Earth is reliable but punishingly heavy. Yet producing fuel on Mars, using local resources, extracting oxygen from the atmosphere, processing water ice into hydrogen and oxygen, manufacturing methane and oxidizer offers a seductive alternative. This idea, often called using local resources, is the closest thing we have to a cheat code. If the return fuel can be made on Mars, the mass you must launch from Earth collapses dramatically, and the mission becomes far more feasible. But here is the catch. It must work the first time. On Earth, we test machines in controlled environments. On Mars, the machine must perform in a freezing desert under low pressure, with dust, with radiation, with long delays in human decision-making. And if it fails, the mission's entire logic fails with it. That's why many realistic plans lean towards sending robotic cargo ahead of humans, land power systems, land habitat modules, land fuel production units, and prove they can operate for months before a crew ever commits their lives to the problem side of media, transfer orbit. Mars demands demonstration, not optimism. In the debate about timelines, this is where certainty dissolves into competing visions. Cautious institutions tend to speak in decades because every subsystem has to be validated, and because the mission is not one leap, but a chain, each link as strong as the weakest. Optimists argue that we already possess the fundamental technology: rockets, life support, navigation, landing systems, habitats. And in a narrow sense, they're right. But having the ingredients is not the same as cooking the meal. The challenge is not a single miracle. It is integration, making thousands of parts behave like one coherent, resilient world for years. And yet the direction of progress is real. We are learning how to live longer in orbit, how to land heavier payloads, how to automate complex rendezvous, how to print parts, recycle air, recycle water, stretch efficiency. Each step is small compared to the dream, but the dream is built from steps. Mars will not be reached by a moment of inspiration. It will be reached the way cathedrals were built, through patient accumulation, ruthless engineering, and the willingness to spend years preparing for a journey that will last even longer. So, the future is not a question of whether Mars is possible. It is a question of whether we can make the mission boring, repeatable, reliable, and survivable. Because only when the journey becomes routine will the red planet stop being a myth and start becoming a destination. And that brings us to the quiet truth beneath the drama: the universe is not stopping us with a locked door. It is stopping us with arithmetic, with distance, with time, with mass, with the unforgiving logic that turns every human need into engineering, and every engineering choice into a new burden. Mars is not protected by monsters or mysteries. It is protected by the simple fact that life is heavy and space is long. When we talk about going to another planet, we speak as if a planet is a place like a city on a map. But a planet is not a place you visit. It is a world with its own rules, its own orbit, its own seasons of alignment that decide when travel is efficient and when it is almost absurd. The moon let us pretend we had become interplanetary. Mars forces us to confront what interplanetary actually means, leaving the cradle of Earth so completely that your species must carry its habitat with it, like a turtle dragging its shell across an ocean of vacuum. This is why Mars produces cosmic vertigo, because it reveals scale not as a number, but as a force that changes what is possible. In low Earth orbit, humanity can reach out a hand and still feel the warmth of home. At the moon, home becomes a distant sphere, but still close enough that the journey feels like an expedition. On the way to Mars, home collapses into a bright point of light. You can still see it, you can still aim an antenna at it, but psychologically, spiritually, it becomes something else. A memory, a promise, a place you might not return to. And that is the existential heart of the Mars problem. To land humans on another world, we must first build a moving island of life and keep it stable for years, without rescue, without resupply, without the safety net of immediate human support. We must solve the physics of propulsion, but also the physics of bodies. the chemistry of fuel, but also the chemistry of fear, the engineering of systems, but also the engineering of hope. Some will argue the obstacle is will. Others will say it is money. And those are real human constraints, but beneath them is something deeper and colder. Mars is difficult because the cosmos is vast and our biology is tuned for a planet. Our minds were shaped by horizons measured in kilometers, not millions of miles. Our instincts expect help to arrive quickly, mistakes to be reversible, and air to be free. Space offers none of that. It charges for everything. Yet the fact that Mars is hard is exactly why it matters. Not because it proves our dominance, but because it tests our maturity. To reach another world, we must become a species that plans beyond a single crisis, that builds redundancy, not out of paranoia, but wisdom, that understands survival as a long conversation with reality. The first footprints on Mars, whenever they happen, will not simply mark a technical achievement. They will mark the moment we carried a living fragment of Earth across the solar ocean and made it breathe somewhere else. So the question is not, why haven't we gone? The question is, what must we become to go? Because Mars is close enough to tempt us forever and far enough to demand that we change. It is a mirror held up to a fragile species on a small world, asking whether we can turn wonder into endurance and whether our dreams are strong enough to survive the distance between planets. Script completed.